Okay, so now we're going to move on to the top part of it. And remember last time we didn't clean up our casting and we ran into a few little tiny problems? Well, we're not going to make that same mistake again. This time we're going to make sure everything's cleaned up, and we're going to grab a combination square and we're going to square it off the back side. This is going to be actually our first step. We're going to grab a big end mill and we're actually going to mill this off at 90 degrees. Now, there's a few options that we could do. We could have bolted this in a little bit differently, and we probably could have face milled it or done a bunch of different things. I mean, heck, we could have even thrown it in a lathe and milled this off as well. But this is the option that we're going to go with today. I mean, realistically, I'm not going to lie to you. I had a brand new one left over from another job, and this would be kind of fun to do it this way. But I mean, however you choose to do it, there's a million different ways to skin a cat. I mean, don't get locked into doing something one specific way, because there's millions of ways to do it. I'm sure somebody's going to let me know in the comments below. So there's a really good example here between climb milling and conventional milling. So we're going to start out here with conventional milling. Now, conventional milling essentially is the end mill spitting the work away from itself, and climb milling is kind of pulling itself into here. Correct me if I'm wrong here, but the end mill is spinning clockwise. I always get confused with that. So looking down on it, the end mill is spinning clockwise, and it's actually pulling the vise to your right. So as it's cutting through there, it creates a lot of pressure, and it's throwing the chips outwards. Now, let's look at an example of climb milling. Now, climb milling's a little bit different, and you can run into a bit of trouble with climb milling, especially if you have an older machine that's a little bit worn out in your ways and you have a lot of backlash. You see, initially when you start to touch your work, it's going to pull that work very quickly into it, and it's probably going to break an end mill or pull something out that you didn't want to be pulled out. And you'll also have little variations in your surface finish. Now, today, the surface finish isn't perfect, but I mean, part of this is in the casting, and part of it's because I did the climb milling with a super heavy big end mill. But I'm happy with this for today, and we're going to move on to the next process. So a mechanical engineer friend of mine said that mechanical engineers are just there to stop people from overbuilding stuff. He says it's the most common problem that we have. And you guessed it, today we way overbuilt this. This was way overcasted, so I'm going to have to cut a lot of this material off on the outside. Essentially because we're going to put a slit in this, and we're going to need this metal to flex. And if we have it too thick, that metal's not going to flex at all. So the idea here is we're going to cut a 1/4 inch off the whole top surface, and then we're going to cut a little groove in there to get a little bit deeper so that we can have a bit more flex. Now, before we start cutting anything here, we're going to have to lock the table because of this whole climb milling and directional pull and whatnot. My milling machine's in good shape, but there's still backlash no matter how good of a machine you have. And I want to make sure when I cut this, everything stays straight on edge. Now, if you missed that before, essentially I just touched off on the top of the work with the end mill, and then I just fed the table up 250 thou, and we're going to essentially call it a day after that. Now, because I didn't dial the head of my milling machine in, there's a very, very slight tilt from the front to back. Essentially, the top of my end mill is kind of facing a little bit in towards the knee that's on the side there. And it's ever so slight. It's like, say, maybe a 1/2 thou, but you can kind of feel it when you get through there. There's a little bit of a ridge right in the center. I mean, it really probably wouldn't bother anyone, but I'm just going to go and kind of split the difference. And I'm going to make sure that I kind of cut through that and make sure that I don't have that little bit of a ridge. Essentially, by a little bit of a thou, I'm creating a little dish in the bottom. But honestly, you'll never see it in the end. And you'd probably be happy with the product if I didn't even do that. Let's move on to the next part of the process after we do a little bit of a cleanup. Speaking of cleanup, you've noticed that I have I think they're Octane Work Holding. They're a really big company, and a lot of guys are trying out these whole like way covers, the blue things you see there. And I think they're working out pretty good so far, but I'm pretty sure we're going to find in the future they have some small limitations, like using coolant, and when I start moving stuff around on the table. But for now, I'm really enjoying them, and it's helping me keep things really, really clean. So now that we bolted it down to the other side, which is essentially a reference side, we're going to do the exact same thing we did on the other side. We're going to bring the end mill around. Careful you don't cut your fingers. And we're going to bring it down, and we're just going to touch off on the top. Remember, this is just a casting and it's not super high precision. We're just trying to bulk off material. And once we have that, we move it off to the side. We bring it up our 250 thou, and we're going to take one initial cut. Now, this initial cut's really important. Remember, we made a reference before to see how much we had to take off. We measured on the bottom side there. And now what we're going to do is, because we zeroed it before, after we cut through on this cut, we can essentially move it out of the way, zero it, and then we'll remeasure it, and it'll tell us the difference that we need to take off. Now remember, we zeroed it on the other side when we took our measurement, and now we took our measurement and it told us the exact amount, and we move it over that 792 thou, and we lock our table in and make our cut, and in theory, we should be right on track for where we should be. I mean, once again, too, we did hit our size, but worst case scenario, if it did move a little bit, we could just flip it over and recut it and make it exact on the other side as well. Remember, this is just a relief cut, and it's mostly cosmetic. So in this video, we did find a little bit of some limitations of the castings that we've had. We have worked our way through it, and I will get to that a little bit later in the video. But for now, everything's going swimmingly, and we're hitting our sizes exactly like we wanted. Now, in here, I'm choosing to go with a ball nose end mill. Now, as we know, if we have straight edges up and down 90 degrees, it can create places that'll create cracks. Essentially, what we're trying to do is minimize the ability for this material to have a crack in it later when we try to get it to flex. I hope I'm not giving away what happens later, but don't worry, I have a second part and we'll explain to you what happens as we go through it. So what we're doing here is we're going to cut exactly on that line there. We're going to run it through, and man, you know, I'm really wishing right now I could go back in time and put that air nozzle on there and blow all the chips out for you. And it's making quite the mess, and you can't really see what's going on, and I bet you it's probably hurting the surface finish as well. But when we flip it over, we'll do a little bit better of a job on that, and we'll figure that all out and make sure it looks a little better. Let's take this out here and see how it looks and see if we did a good job or not. Well, it's not looking too bad. Let's flip it over to our reference side and do the other side exactly like we did on this side. Now, all of your safety gurus are probably going to give me crap at this point because I'm using essentially compressed air to blow the chips away from everything. And you could have a couple of things happen to you. You could have things fly into your eyes, or guys are really, really worried about the compressed air or the blower throwing chips into the waves. But I'm pretty sure with all the shields I have on here, we're safe there. So the next process that we're doing here is we're going to spot face, and then we're going to select the drill size so that we can tap this hole all the way through. Now, what we're doing here right now, oh yeah, and by the way, obviously I forgot to lock the table. I mean, I'm not perfect and no one is. But what we're going to do now that we've kind of figured that out is we're going to figure out what drill tap we need to have. And we know the thread size is a 5/16 by 18, and this is going to be, I believe, an F. And then we're going to go over here because I'm not sure if we have an F, and it's going to give me my decimal equivalent. I mean, you can go up a thou or two if you don't have an F, and usually you're okay. And lucky for me, today we do have an F. However, she's looking a little bit mangled because of yesteryears and not clamping things down proper. Now, we have to be careful when the shank of the drill bit looks like that, because sometimes it can actually throw the size a little bit over because the drill will be wobbly. But today, the only problem that we're having is it's not throwing it oversized. It's actually causing the chuck not to grip it. Now, because of this, I mean, we'll see here in a second, see it stop spinning there. This can actually spin in the chuck and actually hurt the teeth of the chuck as well. So we got to be really careful that we don't do that too much to our chucks. So one of the problems that I have is I don't actually have a 5/16 by 18 on hand, and I'm going to have to order one, but it won't come in until tomorrow. So over to my dad's place I go to borrow one. Speaking of my dad gave me this, out of all the stuff in his yard, he gave me this old Miller welder that had a blown up motor on it. And unfortunately, this is going to be a YouTube project, but it's going to be a personal project of mine because I scooped up this Onan generator, which has a very similar motor on it, and I'm going to rebuild it in my spare time and get a welder back on my truck again. I kind of miss my old welder that I had. Speaking of projects, I got projects everywhere. I just rebuilt this 8-horse Honda. And let me tell you, man, I've got projects you wouldn't believe. But at least before I left the shop, I was smart enough to order off KBC Tools and order the stuff that I needed, which arrived coincidentally the very next day in a 3-pack of 3 different assorted parts. Lucky for me, Dad was out working in the yard, and he had a 5/16 tap that I needed until the one that I needed showed up the next day. Now let's take a quick second to talk about the 3 different types of taps that I have here. The first one that I have here is a taper bed, and it has a taper over 7 to 10 threads. Now, the next one that we have is a plug tap, which is 3 to 5 threads, and then the bottoming tap, obviously, which is for the bottom, uses 1 to 2 threads, pardon me. Now, this is really important because if you're bottoming out on a hole, you don't want to have that taper, and you want to get maximum thread engagement that you can. Or if you're freehanding it, you want to use a taper, and you want to slowly get it in there, and it takes less cutting pressure to actually use that. So also, speaking of getting it straight, I'm going to use this new Fangly Dangly tool that I got, and I'll put where I got it in the notes below, and it works out really, really well for getting things straight when you're tapping in a drill press. Now, it has this little pivot pin that fits in your drill chuck, or call it whatever you want to put it in, and then essentially you can bring your drill chuck head down, kind of slightly lock it in place, and it's going to keep things perfectly at 90 degrees. And not only will it do that, is it'll pivot downwards as you spin it into your work, and it won't bind up. I mean, you could technically do this in your drill chuck, and I have, but there's a lot of downward pressure that's being held back by all the mechanisms of your milling machine or your drill press. The only thing you have to remember is you just got to keep edging it downwards as you're moving down, and as you come up, you're going to have to make sure that there's a space in between it so it has somewhere to go. I'm really impressed with this tool overall, and there's 3 different sizes you can get. I believe like 0 to quarter inch to half inch, and half inch to 3/4 or 1 inch. I'm not exactly sure, but I'll mention that in the notes as well. One of the things that I did forget to say here is, after I drill the hole and slit this, I'm actually going to cut a relief hole on the other side so that there's somewhere for those threads to go, and then things will actually tighten down. That'll make a little bit more sense as we go into the video. But for now, let's flip this bad boy over and start facing off some of our sides and drilling the hole that this is actually going to fit down on the shaft so we can move forward with this. Now notice I'm using the reference sides that we machined earlier on the sides of the chuck. This is going to be important later if we make a mistake or we have to take it out or use those reference sides again. Essentially what I'm doing here is I'm making sure everything's pretty and at 90 degrees and has a nice little shoulder on it. It's not overly necessary, but I'd like to do it because it's just going to look better in the end product. And you know what I forgot to order? Is more cutters for this face mill. It is one of the forgotten bastard childs that I have in my shop. And I'm telling you, I always keep telling myself I'm going to order new ceramic inserts for this thing, but I never do, and then when I need it, I don't have it. It's just one of those forgotten mysteries, like where does that extra sock go in the dryer, or is there a Loch Ness Monster? But anyways, I digress. So let's get back to working here. Now, the next step here is going to be, no, not drilling the hole. It's actually going to be finding the edge off of the parts here with the edge finder. But before we do that, we have a bit of a burr on either side. And if we have that burr left on there, we're not going to get a good edge finding because that burr actually has a bit of depth to it, and it'll push it off to the left or the right or front or back or whichever you want to say. And it won't get us a good accurate find. Also, if you look really closely here, I've also made another mistake. But we'll get to that in a minute here. But because we're doing the edge finding, it won't be that big of a deal. And because we have those reference surfaces. Now, I'm not going to go too far into edge finding here because we have a whole edge finding video on this. I think there's like 12 different ways to find edges or something like that. I'll put the link in the video below. But essentially, you're just going to run it up till it kind of moves off to the side. You're going to press 0 on your DRO. Hopefully you have that. And then go over to the other side, and that's going to give you the number. Now, you just need to divide that number by 2 with some quick, high school math or grade school math, and you're off to the races. And essentially, you're going to move it over to that, 1.022. And whether you hit 0 or not, that's totally up to you. But you got to make sure you lock that bad boy in. Whatever happens, at least it won't move left or right or off to the side. Because we're kind of designing this as we go, we're actually going to cheat a little bit here. We're going to grab a bearing and we're going to line this up visually by eye, left and right. And that's okay because we're kind of in the R&D phase of this whole project. Now, have you noticed the problem yet here? Well, I've got it centered and this is going to work, but before I start drilling here, we're going to run into a major problem. And I'm pretty sure you've figured it out by now. We're going to drill into that table underneath here. So we're going to have to put a parallel in there. We're going to have to raise this part up and then clamp it down and take the parallel out so we don't drill into that table. But pretty much everything is going to be within 5 or 10 thou, and we're not going to be out too much. I mean, remember, we referenced everything with the center finder and then we put it back in the exact same spot for the most part. So I'm pretty sure we're going to be okay here. Let's drill that hole and then we'll get on to the boring part of the video. Or boring, you know what I mean. And it's really important to kind of double check your work to make sure you have those clearances so that when you drill through, you don't, drill into the vise, because I've seen that a lot in the school shops and it's not really a professional thing to do, and you're wrecking really expensive tools if you do this. Now, let's take that drill bit out of there and we're going to throw the boring head in and we're going to bore this hole here. Now, speaking of mistakes, this is going to be our reference cut. Did you notice the mistake that I made there? Well, maybe I won't tell you quite yet. Let's cut this hole and then we'll talk a little bit more about it as we go through it. Essentially what I'm doing here is I'm going to do a rough cut, and this is what I'm going to measure off of, and then I'm going to do my final cut off of this cut here. So essentially, if everything goes good, I'll take my measurement and then I know I need to move the 30 or 40 thou, and then we can go and move that 30 or 40 thou and cut it, and we should in theory be perfectly on. Now let's talk briefly about the mistake that I made there. The mistake that I made was actually backing the boring head off. Now, so one of the problems that you have when you back the boring head off is you have that backlash. That's right. Essentially, when I backed it off, there's that little bit of movement in the thread. And as I'm cutting down through this whole process, it starts out kind of working good, and then it moves a little bit, and I'm not actually cutting to the size that I thought I was cutting to. Now I'm going to take this reference measurement, and then I'm going to move the boring head the desired amount that was left over. And the desired amount left over probably isn't very much, and I'm going to move it obviously the correct way this time. Now underneath lurked a little bit of an error, and I'm going to pay for that later, because when I pull this out, I'm actually going to be about 5 or 6 thou over, which in the grand scheme of things isn't a big deal. But in this project, it is actually going to be a big deal. But we're going to get a little bit more into that at the end of the video. But the process that I'm actually going to do here, and I'm going to repeat the same process on each one, is I'm going to bore on the way down, and then I'm actually going to bore on the way up as well. Now, the reason for this is, for some strange reason, I get a better surface finish when I bore on the way up. Now, if I do things the same each time, which I did on the first time, except for turning the dial the wrong way, and then I do it on the final cut, in theory, I should have it the same on the final cut, right? But not today, because I turned it the wrong way. And the moment of truth. I mean, we can't all be perfect all the time, and I know you've missed sizes as well, so I'm not overly too embarrassed, but this is the way it goes, right? So onwards and upwards, we're going to use our de-burring tool to take off a little bit of that burr that's on the outside there, because I mean, this kind of finishes up a quality part by taking off all those sharp edges. It's amazing what you'll notice by hand when you touch a part if you have a sharp edge on it, and the difference you'll feel in quality between what has a sharp edge on it and what isn't. Even if you miss a size, it'll still feel better if you don't have the sharp edges on it, and you might not detect some of the errors. Kind of what I'm trying to hide here, maybe. So the next step that we're going to do is we're going to put the pivot point on this part here, and this is what's going to pivot the overall head once we put this on the shaft. We're just going to grab a small little machinist square and level everything out and make sure it's true up and down. I mean, it doesn't have to be perfect, but I mean, we're shooting for pretty good here, right? Then the next step after this is we're going to have to find center in the overall center of that, well, not so round casted part. And I've got a solution in store for us here. Let's make sure that's tight, and we'll come back to it. And let's go grab that tool I was thinking about here. Now, this one doesn't come out very often, and I actually have it as part of my combination machinist square, but I thought, what the heck, I'll bring this one out today, and we'll use it and show you what we can do with it. Essentially, this is going to find a center in a round part. Now, this is a little bit off, so we're going to guesstimate it. So essentially, we're going to turn it in 6 different places, and in the end, it's going to show us kind of the crosshairs of where that center is, and then we can come back here and find it by eye and drill that hole with the center drill. Now, I want to make sure I get this actually pretty center here. I mean, it is an odd shaped part. I mean, because it's cast, it's not perfectly round. So, like I said, I want to make sure we get this perfectly in the center here, because when we turn this later, if it's not in the center, you will notice some of those oblongs that are off to the side. They may look even more off to the side, and we don't want that to be picked up by the eye when we turn this. In the end, we're going to put a stud here, and I've got a stud package that I'll show you here in a second that's going to work just perfect for this. And it comes with everything we need for a clamp down kit. Unfortunately, I don't need the clamp down kit, but I need most of the parts that are going to come with this. I'm pretty much going to use everything out of the package, except for the T-slots. And I mean, you never can have too many T-slots, because for some reason, like socks in a dryer, you're always missing one here and there, and you never know where they all went. So one of the things that I had problems with was ordering T-slots out of all things. And lucky for me, I got lucky with this and ordered one that just fit my milling machine, but I thought the T-slots were originally actually going to fit something else. Now, T-slots sometimes are measured by your 1/4 inch stud that goes into it, not the actual top with the gap, the opening on the table. Man, I don't know. I can't quite really figure this one out. Essentially, I got to go to a reference every time in the machinery handbook and make sure I order the right one, or I look for kind of notes on, say, KBC Tools. They'll have like a note of what the dimensions are, and I always got to double check before I order it. But let's get back to the project. So what we're going to do here is we've got the right size drill. We're going to drill into the work here, but I'm not going to drill all the way in through the other side. Like all the other stuff that we've drilled today, we went through to the other side. Now, the reason I'm not going to drill through is really, really simple. I want just to have a little dimple showing through here. Now, the reason for that is when I put the bolt in there, I don't want the hole to hydraulic, which means essentially it creates like a little hydraulic situation, and you think you have it bottomed out, but it's not bottomed out. And speaking of bottoming out, I'm going to grab, for the most part, a bottoming tap, and we're going to use our new tool that we have. And we've seen a lot of success with this tool, and I'm really loving this. And let's fit it up into the milling machine and tap this hole through with a bottoming tap. Now remember, we talked about bottoming taps already, and they have 1 to 2 threads on the bottom of a taper. Whereas when you have a tapering tap, I mean, you got 7 to 10 threads. But we've talked about that already, and let's get back to the project at hand and tap this thing through with our new awesome tool. Now, did I mention, which I did, I love this thing. I mean, the only thing I think we could do better here is if we built one of those self-tapping arms where you like come over with the hand and come down. I mean, I'm seeing A-Bomb and some of the other high-end guys have it. To be honest, I'd love one, but I don't know if I have the room in such a small shop for such a cool little gadget. Maybe that's a build down the road. We could build one of those. But man, I got so many projects. I got to get that welder rebuild first. In fact, the funny thing that I've kind of realized, the older I get, the more projects I have, and the less time I realize I have to do all these projects. So we kind of got to triage the projects, so to speak. Let's blow this off here. Hopefully we don't get any metal in our eyes. And let's go grab that shifty Loctite that has no label on it and liberally apply this, because this is a one-way trip for this stud and it's never going to come out of there. And if you're new to machining, or I mean really new to machining, what we're going to end up doing here is we're going to do the double nut lock in this. So essentially what we're going to do is we're going to put one nut on, then we're going to face the other one off, and we're going to tighten the bejesus out of these two nuts together on themselves. And then essentially what we can do is we can turn that stud all the way in without having to get kind of messy with using vice grips or like an acorn nut or anything like that. And this technique's worked pretty good for installing studs and even removing studs too. And I'm sorry if this is really basic for some of you guys out there. I know you guys have all seen this before. But you know, some of the junior guys out there, maybe this is something new. Maybe or maybe there's another technique that I don't know about for installing studs. But I digress. Let's get these nuts off of there and let's get back to work. So the next step that we got to do is we got to cut that slit in there for that 1-inch hole that we bored, so that we can actually clamp this down onto the post on the table. Now, I ran into a bit of a kind of conundrum here. Normally you'd say we'll just use a slitting saw, but unfortunately the slitting saw just wouldn't go all the way through. So I had to get a little bit more creative. I mean, I could have started with it, but I've done this before, and there's a little bit thing in the middle, and then you try cutting it with a bandsaw and you make an absolute mess of it. So what I came up with is I'm going to have to hit it with a 1/4-inch end mill from both sides. Now, on first glance, it looks like it's easy, but there's a few things that I got to be careful about here. When I clamp this, I got to clamp it all the way in so that it's actually clamping on the far left there. You see where the corner of the jaw is barely? Because when I cut through this on the other side and I get all that material removed, if I don't do this right, it's actually going to want to clamp down on that end mill. And I've done this before and it never ends well. I usually end up breaking an end mill. So we'll have to be very careful as we go and make sure this is clamped correctly. And I know there's a safety guru somewhere that is just going to wear out his keyboard on how unsafe it is to use compressed air on a milling machine or any machine whatsoever. But I mean, let's be honest here. This is my shop and my rules, and these are the risks that I'm willing to take. And if you're not willing to take these risks, I mean, you got to know your limits and play within them, right? So now that we're quite aggressively working our way over through to the other side, we can probably look at flipping this open. Now, one real important thing here that I got to point out is we got to make sure that we keep to our reference side. So the fixed jaw for that side, when we flip it over, has to be on the same side. Okay, so in layman's terms, if we didn't flip it over like this and we turned it upside down or did some weird stuff, we might be cutting on the wrong side. Essentially what'll happen is rather than having a really straight through cut that looks like it's kind of machined perfectly, it'll be machined to the left on one side, and then when you flip it over, it'll be machined to the right on the other side. And we don't really want that. We almost want to make it look like it was cut with a slitting saw. And I assure you today, it might look a tiny bit rough because of the multiple cuts on it. It turns out quite well because we kept to that rule of staying with the reference side. And one of the things I forgot to mention as well is this is an extremely cheap, like Alibaba Express end mill that I had sitting in my drawer, and I'm really surprised that I actually got to cut through a whole job with this, because these AliExpress cheap Chinese end mills are only good for wood, and I only normally use them for the router. But in the end, I mean, I'm reasonably happy with that. Now, let's take this out, clean it up, and have a little bit better of a look at it. I'm pretty happy with it so far. So we're going to throw that little stud in there, and this is what's actually going to clamp that, collar together. But there's a bit of a twist here. Now, the problem that we're having here is one of two things. One of the first problems that we have here is we cut it a little bit oversized, only a mere 1/10 thou. And the 1/10 thou mixed with the material being really frangible. In other words, we should have either normalized the aluminum or we shouldn't have done this with a cast part. I'm still trying to figure this mystery out, and I'm probably going to have to do a whole bunch of watching of other guys' videos like Kelly Caulfield to see what they've done with these parts before. But lucky for me, I have a second part here that I machined and I threw it on, and this is going to work just fine. We made sure this time, though, that we cut it right to the dimensions of just a little bit over 1 inch, and we don't have this failure like we did on the last part. I'm pretty sure most of that failure came down to the aluminum being super brittle, but what do you guys think? Do you got any ideas? Next on the way, let's machine up this part here, and that'll be the next video. If you want to click in the top right, you can check that one out too.